and capacity building, scientific and educational interest of individual, and it's a local chapter of as the Association of Energy Engineer, AEE, that is based in USA. The association is composed of experts and professionals from different fields in the energy sector. So I'm very grateful for all of you who have made time to attend this session. And our talk for today, sorry, I'm having an issue. So our discussion for today will be about solar technologies. This is paving the way to a sustainable future, where we will dive into how solar power is reshaping our energy landscape, helping combat climate change and creating new opportunities in the green economy. So our speaker for today is Bonke Mseve Mulama. He's a dedicated solar engineer with over 4 years of experience in the field of the solar energy. His experience spans the design, installation, and maintenance of commercial solar system, showcasing his commitment to advancing sustainable energy solutions, that is SDG 7. He's also the founder and the managing director of Be Your Best Foundation, where he leads a vibrant force of positive change in Kenya. So without further ado, it's my pleasure to welcome our esteemed speaker, Bonke Mulama. The floor is yours. Thank you.
Thank you very much. It was a very nice introduction. Let me just load my presentation. All right. Yeah, hello energy engineers and green energy enthusiasts. I'm grateful for this opportunity and I hope I'm audible enough. My name is Bonke Mseve Mlama and welcome to the Association of Energy Professions webinar, which is proudly powered by Be Your Best, which is a hub of young professionals. And today we will discuss about the potential of solar energy. And at the end of this webinar, we will all understand where we need to align ourselves and to take advantage of this. Feel free to comment in the chat box as we go on. So I'll begin by reintroducing myself. I'm Bonke Mseve Mlama, the Managing Director to Be Your Best. I'm a Masters of Science Energy Technology student. I'm a certified occupational health manager and professionally a solar engineer. For my passion, I'm a youth mental health counselor and aspiring life coach. They are my contacts. So please confirm if you can see my slides so that you can proceed. Can you guys see my presentation?
Yes, your presentation, we can see it.
Okay, thank you. So with all this, I earned the title of Sustainable Evangelist, where I contribute positively to tell people more about sustainable energy, sustainable future. So to crack the ice, I will pose a question. How often do we hear the word sustainability? This is a question maybe you could ask yourself. And I'd answer it by saying, sustainability is just a buzzword, but it echoes the ideas of our time. And solar stands at the forefront of this green revolution. And so why do I pick solar? I'll pose another question so that you can understand this. I'll ask just a random question. How many people here own wind turbines? And just you can review yourself. Do you own a wind turbine? And how many people here own a hydroelectric plant? And because this is not a live audience, you can't get the real statistics. But compare with how many people own a solar power. Yeah? So it is evident that solar energy poses a unique advantage. And that's why we're here today. We want to talk, why is solar energy unique? And why are we saying it's the key to a sustainable future? So solar has a unique advantage for residential installation and private ownership. Solar power is not just an alternative, but a necessity for a sustainable future. I may not be a prophet, but I foresee a world where every home is powered by the sun. With solar water heating systems and solar photovoltaic systems as standard fixtures in most, if not all, homes. And to bring in the numbers, I will check April statistics. If you read the April report 2024, which was released in June, and in the reports, it states that currently 12% of the total installed power is solar power. Of the total installed power supplied in Kenya is solar, which ranks third among the renewable energy sources. That is currently in 2024. But why are we saying that solar is going to unlock a sustainable future? So you are saying this because overseas, there was a study carried out by National Renewable Energy Laboratory, which published a report whose findings show that with aggressive cost reductions, supportive policies, and large-scale electrification, solar could account for as much as 40% of the national electricity supply by 2035 and 45% by 2050. Yeah, you guys think that 2035 is far. Yeah? And to understand the future, let's rewind a bit to my past. Well, tell you a story of my first interaction with solar. And this was a few years back. This was a few years back when I was in Form 2 in Musingo High School. There was one time that I came home for holiday at my grandmother's home in Kakamega. And one fine morning, one of my uncles came from Nairobi, our capital city, and brought us some shiny glass-like equipment with a metallic frame, which he called solar. And wow, uh, it was very spectacular. So under the guidance of my uncle, who had no electrical background, but had seen the connection done somewhere in town, we did 1, 2, 3 and connected the solar to an old car battery. It wasn't easy because we were relying on my uncle's memory, what he saw in Nairobi. But after several attempts to recall how the connections were done, we were able to light up some bulbs at my grandmother's house. Yeah, they should clap for us by now. And this was actually a village wonder, as many people would come at night to witness this mysterious source of power that brightened up my grandmother's home at night, way in Kakamega, the middle of the village. There was a house uh, lighting up at night. So the solar panel, which I later learned was rated 40 watts, combined with a car battery, marked my first ever solar installation way back in 2014. That's why I'm very confident when I declare I have 10 years of experience in the field of solar installation. This is a point where you can clap for me also. So there are very few of us who have this kind of experience. On a light note. So from this village wonder, I would say that the potential of solar energy is limitless. It surpasses the traditional boundaries, finding its place to the modern electric vehicles and building integrated solar modules. As technology advances, solar products are becoming more portable, more compact, more affordable, making solar energy more accessible than ever before. And just a bit about the evolution of solar so that we understand where we came from to where we are right now. We all remember back then, we used to install very huge, big size solar modules with low output. An example was an 100-watt polycrystalline solar panel was about 1 meter by 0.5 meters. That was 100 watt. And the price was going for about 100 shillings per watt. So only the rich people could afford this, or the area chief. So if your grandfather had a solar system, he was either very rich or was the area chief. There were only those two. The rest, ilikuwa and staying in the darkness. So there was no distinction between solar and the car batteries. And the car batteries then, after some time, required to be recharged by electricity and topping up of water, distilled water actually. I know Generation Alpha remember this very well. The charge controllers were not the best. And actually, at midday, and about midday when the sun is at the peak, the battery will be seen to bubble due to charge saturation. I can bet no Gen Z has experienced this phenomena, but I hope you're with me together. So currently, as we speak, the solar modules are monocrystalline and the size has halved, if not smaller, whereby a 550-watt module is about 2 meters by 1 meter, and the price dropping from 100 Kenya shillings to 18 Kenya shillings per watt. Mathematically speaking, this is a very huge drop in pricing. So, so um, just to touch about energy storage, you could see how the battery or energy storage systems have transitioned. And the battery technology is evolving by day. And the introduction of lithium batteries that are maintenance-free with 10 years warranty is actually a game changer. The introduction of smart inverters that have inbuilt MPPT, charge controllers, and online monitoring capability has actually sealed the deal. Energy storage systems and flexibility in generation are key to maintaining grid reliability and resilience. I was happy to discuss with the Muresa Renewable Energy students about energy storage and balancing supply and demand in smart grids. They are in Multimedia University during their Clean Energy Week. And it shows that the scholars are aware where the world is heading, which is a good thing. And just to tell you another prophecy, in the coming future, blackouts will be a thing of the less fortunate. The blackouts will only be observed in the ghetto because most industries, houses, and institutions will have battery banks. Small-scale solar, especially coupled up with storage, can enhance resilience by allowing buildings or microgrids to power critical loads during grid outages. So the sooner you get yourself an energy storage systems, the better. And the demand of solar is on a steady rise. We all notice around us. If you look around your estate, your neighborhood, where you normally visit, and you'll see that most of the institutions, houses have solar on the rooftops. It was barely 2 years ago that solar panels were a rare sight in an industrial area. But currently, they are found everywhere, with most buildings sporting ongoing solar installation works. For those who walk around the industrial area know this. And this is just an example. If you go to all areas that have industries, you'll not miss to find an ongoing solar installation. And why is this? And I would actually advise the Gen Z that solar energy is not just a passing TikTok trend, but a long-term investment. Financial institutions have recognized this opportunity and are now offering financing options that leverage these lucrative returns and investment that the solar systems provide. So looking into the future, solar industry is poised for exponential growth. Companies are eagerly seeking to integrate solar systems into their operations, with projections suggesting that 70% of industries will be solar powered in the near future. As initial maintenance contracts expire, most of them run about 1 year, if the longest go about 2 years. So uh, as the most of the maintenance contracts are expiring, there will be growing demand of solar monitoring and maintenance services. So looking into the photo that is displayed, you can see that the shift signifies a new era where installations of solar systems becomes as common as clean water. I hope the photo is a bit clear. You could see that in that photo that I've shown there, a lot of the houses there, a lot of the houses there have solar power in their rooftop. And this is not an AI generated photo. This is actually a real city, but not in Kenya. And I would say that this will be this will be a common sight in Kenya in the near future, whereby in most estates, we'll be getting houses that are the rooftops all have solar power. As you see, the policies are now being drafted to actually promote this transition, whereby there's a policy of net metering that was published in April, in June. So I would say that this will be a common feature and a common sight in the near future. So prepare yourselves for it. So the role of operations and maintenance engineers will become increasingly vital as companies manage multiple solar sites across regions. You get that the companies that are currently in the market have a number of sites they've installed and managing. So operation and maintenance, after most of the industries have solar, now the next job will be operation and maintenance. So these professionals will actually be the custodians of solar efficiency, ensuring that the sun's energy is harnessed effectively. I always tell my friend who is a solar operation and maintenance engineer in one of the companies, the solar companies, that she's a step into the future because this role will be very key in the near future. The installation will decrease, but now the focus will shift to operation and maintenance. So achieving decarbonization requires significant acceleration of green jobs. And these jobs will actually employ millions of technicians by 2030 around the world. So solar engineers or solar engineering is just an example of the green jobs. So embrace yourselves for this. So to conclude, I will say that solar energy is not just a component of energy sustainability, but it is the cornerstone. For those looking to be part of this sustainable future, the time to act is now. Because the more you wait, we don't know we don't know about tomorrow. And It is now absolutely necessary to invest in skills. And what skills are these? Skills such as interpreting performance curves, troubleshooting solar systems, understanding inverter communications, mastering basic maintenance practices, and understanding energy economics. These skills will be very marketable in the near future. So align yourselves with it. There are various courses that offer this, and for smart scholars, you should be able to have these skills at your fingertips by now, so that in the near future you'll be very marketable. And I have news for all of you today, that the solar surge is here. I repeat, the solar surge is here, and it's time to ride the wave of renewable energy into a brighter and greener future. Lastly, I will say that we need to embrace your potential, ignite your passion, seize every opportunity. At your hands now is the power to be your best. Thank you very much. It was just short and sweet as that. Thank you. So I, I hope I'll return the mantle back to Cynthia. I don't know if we'll have a question and answer session or we can.
Thank you, Bonke, for that. For now, we'll have the question and answer session. So for those who have question, it's your time. You can pose your question to Bonke. While we wait for the question, I have a question for you, Bonke. So which area would you advise students to look into while venturing into the solar industry? And also apart from the operation and maintenance and the installation, what other role can a student in renewable energy do in the solar industry?
Yeah, that's a very good question. And I will start by giving a testimony that I got my first job in one of the solar companies here in Nairobi before I graduated. And I'm a testament that as a student, you can get employment in the solar industry, because the solar industry right now requires skills more than the papers. And to answer you, I'll tell you that there are roles such as solar design, whereby if you're very conversant with AutoCAD, PVCs, Solar Edge, SketchUp, and a number of designing tools which are taught in campus or even in YouTube, you can be able to land yourself a very good job in one of the companies here in Kenya. Because also there is a role of solar monitoring and maintenance. If you're able to understand the PV curves, you can land your job as solar monitoring and maintenance. Also, uh, you can also become a solar engineer like myself, and you can also become an operation and maintenance, as I mentioned. There are a number of jobs. Also, there are these financing companies that need expert advice when investing in solar projects. There's a very huge gap that is coming up, and it's actually solar consultants. So for you, as long as you have the correct skills, you're very conversant with the energy policies, energy news, you can have, there's a number of jobs depending on your creativity. I usually get a lot of uh, notifications from LinkedIn because these green jobs are popping up day in, day out. So maybe some of them I've not mentioned, but there's a number of even in the technical side, there's technical leads, installer installation, and there is also project management if you're not, even if you're not an engineer, you can manage a solar project as long as you know the stages of solar installation. So you have to just get a refresher course and know how these stages in the solar project go. Yeah, so I see there's someone raising the hand. Jerry. Is Jerry. Is it Jerry?
Yes, it's Jerry. So okay, I'm still a student. I'm doing a bachelor's degree in electrical and electronics engineering.
Yeah.
Can you hear me?
Yeah, I can hear you, but speak louder.
Okay, so like I got it. Okay, during my attachments, I got some opportunities to go to assist in solar installations at a certain company. So it happened that most of the time when we were doing the installations, okay, the the person who was in charge always told us that they don't connect the solar system to instant showers and all those, like on the instant cookers, like and the cookers. So like, is there a way that maybe you as a solar engineer, or maybe your department, or let me say something of the sort, you have come up with ways to solve such instances, such that maybe we can use solars for instant showers and maybe for cookers? Yeah, that's all.
Yeah, that's a very good question. Actually, it shows you're a student or you're part of this field, because that is one of the common challenges I've seen clients complain about, where they've installed a solar system to their house, but the technician will tell them they cannot use some of the appliances, such as microwave, oven, instant showers, just to mention a few. So what is the point of having, I always ask myself, what is the point of having a system that is over 100,000 and you can only use it for lighting and light loads? Because for you to realize return on investment, you need to offset the big loads, which you're given an example of the instant showers. And just to give an example before I now get you to understand this, one of these companies that does melting of steel, right here, if you guys are in Nairobi, you know the Tononoka Steels. Tononoka Steels uses solar power to power their engines which go to melt the ice, to melt the metal. So that is just an example to show you that solar has the potential to do heavy duty works in the industries and out there. So what do you need to do for you to offset these loads? And the step one is always understanding your loads. You need to know you have instant shower, ovens, light loads, and you know your energy patterns, whereby most of the bulbs will be lit from 6 p.m. and by the time people are sleeping, they'll turn off the lights. And for the oven, they'll use it for cooking, so you can estimate the time of cooking. So when you understand your loads, it goes now to the next step, which is sizing. And if you miss to size your system well, it will not accommodate most of the loads. You've seen some of us having inverters that are, you get your inverters that is 2 kVA in your house, and it cannot support a load such as an oven. So when you do a sizing, you need to understand your peak load demand, so that if you want to get return on investment, when you omit these loads from the solar system, you'll not get return on investment. So for you to accommodate these loads, your sizing needs to be correct, and the size of your battery also needs to be correct. whereby when you have an oven and you have an instant shower, you don't want a scenario whereby people go to shower after job, maybe 6 p.m. to 7 people are showering. And then if it's an off-grid system, by 7:30, the system is down, low battery. So you'll not be comfortable having a system that doesn't actually go through the night. So you need to understand your energy pattern. Also, you need to have a very credible system. Right now, we are facing a challenge where most of the items that are being sold are counterfeit, where you think you're buying a battery that is 200 ah, but in real sense, it is 100 ah. So as a bandage solution, you'll get the technician will do load separation and put some loads back to KPLC. But for me, I usually advise my clients to, if you size an inverter, mostly 5 kVA inverter can support all the loads in a residential unit. And a battery system of 10 kilowatt hour is usually serves a residential unit very well. But you can either upscale or downscale depending on your use. And also sizing of the solar panel. You need to size your solar panels in such a way that they'll charge your battery to full. If you downsize your solar panels, you'll have a big battery bank, but does not get full. So I think I've mentioned some points that, Jerry, you can, in case you have any other additional question, you can ask. I will give the chance to Goretti Royans. Yeah, such a unique name. Goretti, if you can turn on your mic, you can give your question.
Okay, I'm also still a student. I'm taking Bachelor of Science in Renewable Energy, Environmental Physics. Okay, my question is how far has the solar sector explored in terms of heat storage? I mean, the thermal heat storage. For example, a system like the solar air heater, how far have they explored the optimization of something like the solar air heater with the phase change materials?
Okay, it's a good question. When you talk about thermal heat storage, basically the principle there is heat exchanger, whereby at night when it's cold, you want to utilize the stored heat. One good example is actually the solar water heater. It's a common example which all of us can relate with. Because in Kenya, we normally don't have the heat exchangers because most of us don't face there's no winter here in Kenya. So most people don't invest in some of the solar heat exchangers. So a good example that most of us have is the solar water heater, whereby you get the water is heated during the day and it's stored in a lagged container. If you actually open that solar water heater, you'll get a very thick casing that is lagged, that heat cannot, very minimal heat is lost to the environment. And this can be used to shower. And another thing, if you have maybe a room that is cold, most people can usually redirect the water to pass through a heat exchanger, whereby you are utilizing the heat to warm maybe your sitting room. And this, as I said, is not usually in most areas in Kenya, but I've seen the technology being done outside Kenya, whereby they utilize the heat that is stored so that you can warm your houses. So I would say in Kenya, maybe the market, in Kenya, people usually invest where there is market. We've not seen great advancement in that in Kenya because the market right now does not have high demand for the heat exchangers, but there's high demand for solar water heaters. You've seen all the houses that are, maybe nearly 99% of the houses that are constructed in this year, 2024, all of them have solar water heaters. because you offset a huge bill when you have the solar water heater. And I will answer by saying that there's a lot of research also being done, and also in terms of return on investment in that. So yeah, I hope I've been able to answer your question, Goreti. Was that not clear? Yeah.
My main focus on the question was, yeah, I know Kenya, we don't, most people don't usually invest on the air heaters because we don't experience some of the seasons. But outside Kenya, like in other countries, like, do they use the phase change materials? I mean, for example, something like the global salt. Do they use it as a method of the thermal storage, or what is the main component they always use in the storage of the heat?
Okay. For storage of heat from solar, you cannot trap sun rays. So solar must first heat something, and then that thing that is heated is lagged, so that it doesn't lose energy to the environment. So, which I've said, a good example is actually those that utilize solar water heating. And also you've told us about air heaters. But air heaters, as we all know, air is not a good component to use, because it easily loses heat to the environment. If you go to the rivers at the evening, you'll notice that the rivers are warmer compared to the atmosphere. So it will be better for you to use water than air when you want to store more thermal heat. And there is a number of technologies. Maybe they've slipped out of my head for now, Goreti. But if you're able to contact maybe after this session, I could give you some examples. They've just slipped out of my mind, but I was reading that some while back, because not many people have actually ventured on that. So it's very rare to get people who are interested in that, and it's a good thing for you, Grady. Yeah, so I can give you some examples maybe later.
I would appreciate that, because it's my area of research in my 4th year.
Oh, nice. We can link up. I'm on LinkedIn, and then you can just search my name, and we can be able to explore that.
Okay, thank
Okay.
you.
Okay, Bonke, I can see that you have some question on the chat. From Jeremiah, carbon analytics is also coming up in the solar field. I'm not sure about the question. Maybe he can clarify on that. Jeremiah, kindly.
Yeah. Jeremiah, you want to add something, or I can add something?
Bonke, you can go ahead, please.
No, you just state, then I'll add.
Okay, what I was just trying to bring on board is that when you are mentioning other opportunities on hand in the solar sector, is carbon analytics that is also coming on board. That is in the solar sector, where you kind of calculate the carbon that you are handprinting with respect to what is being offset. So it's something that if you're interested in, you can look into it. Yeah, that's what I wanted to bring on board. Thank you.
Okay,
Yes.
thank you so much for that insightful comment. And the other question is, list some of the financial institutions that support renewable energy.
Okay. I'll start with that of carbon analytics. This is actually one of the green jobs. Actually, I didn't mention in my presentation, whereby an industry that utilizes green power, solar, geothermal, solar water heating, any green power that there's some calculation. These days we have softwares that calculate the CO2 saved. If you have a solar system and you're doing monitoring, you'd realize that there is a place where it calculates for you the CO2 emissions that are saved. And in future, as you saw in the energy summits, the climate change, the energy summits, the Renewable Energy Congress, there's a push for policies to promote carbon credits, whereby these CO2 emissions saved will be calculated and you can trade in that with incentives or money or points that are redeemable. This will work like just the way you go to supermarket, you shop, and then after some time you earn some points which are redeemable in the same supermarket to buy some items. So the same concept will be used in carbon credits. So it will be an advantage whereby we'll have net metering so that if you have, you're not limited to the solar installation you install for your residential units. There'll be a time where we'll be putting solar installations to the maximum at our rooftops. And we've seen building integrated solar modules coming up. This is because people will be striving to produce as much green energy as possible because you'll be earning carbon credits from it. And also there'll be net metering where you'll be selling to the government. So if your house is using maybe 5 kilowatt hours of energy in a day, and you have a big roof, you can install solar to the maximum of that roof and export the surplus. Maybe you'll be able to produce 10 kilowatt hour in a day. So the 5 kilowatt hour daily, you'll be exporting to the grid. Number one, you'll earn direct income from that. And number two, you'll get carbon credit from that. So there'll be very specialized professions who will be calculating this. And it's called carbon analytics, whereby they can be able to even extrapolate the data and tell you in a month, this is the estimated amount of money that you can get in a month. So some companies will actually invest in that. So if you're smart, you can start reading at these carbon credits because it's actually the future is heading in that direction. So that's a good point, Jeremiah. So there's a question here from Francis, and he's asking to list some of the financial institutions that support renewable energy. Support is, I don't know if Francis can be able to elaborate what he means by support. Do you mean that utilize renewable green energy, such as solar, or support renewable energy in terms of, I don't know.
Hello.
Yeah, Francis.
Yeah, good evening.
Good evening.
I was asking if there are some financial institution which finance renewable energy. Because right now we are looking for some of the partners which we can venture to list to ownership. That's what I'm asking.
Yeah, thank you for the clarification. And the energy economists will tell you that the biggest challenge in green energy is actually the capital. There is no green energy that is cheap. To the initial cost, it's cheap because you require one or two systems to be installed. So the biggest challenge is actually the initial cost. And financing companies have come in because they've noticed a lot of industries are not going green because of lack of capital. So these institutions that are coming in are calling themselves financiers. So that the financing options have been increased from turnkey option. Now we have two additional financing options, which include the lease to ownership, whereby you pay a percentage of the initial cost, and then the third party will go to finance the bigger percentage of the capital. And then you'll have a monthly payment plan that can be spread even up to 4 years. Some companies even doing more than that. So that is the lease to ownership financing option. And the other one is the power purchase agreement, whereby financiers install the system at your premises at zero initial cost. And then you purchase power from these financiers instead of buying it from the normal government or KPLC if you're in Kenya. So these power purchase agreements come in to get rid of the initial cost. And there are some companies that actually do that. And mentioning them here actually will be free advertisement, but I'll just give I'll just give maybe an example of companies that do this that I've heard of. Okay, I don't know if they do it up to now, and I stand to be corrected. There is Avenue. There is Avenue as an organization. There is Berkeley Energy. There are a number of them. Maybe if you can link with me later, I could give you the list. There is a number of them that are doing this. There are also banks that are doing it. There's some banks, I won't mention the banks here because of the policy of IPEA. But if you're a member of this bank and you want to install solar, they can pay 100% of that solar installation for you. And you're normally, because it's your salary account, so every month, a percentage of your salary will be going to offset the debt. So there are banks that are doing this to their clients. So you can either use your bank or you can use the third party that are promoted with the solar installation companies. So when you reach out to me, I'll give you this list. Yeah, and I'm seeing there is Gideon Kitum is asking, how do recent technological advancement in solar efficiency and energy storage impact the types of roles available to manufacturing engineers in this sector? How do recent technological advancement? Maybe Gideon, you can shed more light to your question as I try to internalize. Gideon Kitu. Is Gideon Kitu able to shed more light? So, let me just answer according to maybe how I've understood the question. Because solar efficiency and energy storage are actually things that have been evolving over time. I've given you a story of how the initial energy storage, the batteries, used to add water, used to, they were maintenance, maybe checking for oversaturation. The batteries were actually manual. I could call them manual. But the energy storage systems of now are autonomous. I was actually happy to be part of the piloting team that installed one of the first energy storage systems in Kenya, here in Enterprise Road, in a very famous institution, which I won't mention the name. So we installed actually the first energy storage system. So these systems are actually autonomous. At the comfort of your home, you can be able to know how your factory is operating in terms of the energy being consumed, how much you're getting from Kenya Power, how much you're saving if you have a solar system. You can able to check how deep do you discharge your batteries. So for energy storage, I will say number one, the systems are autonomous. So the role, if there was someone there who was in charge of maybe in case of a blackout, is the one going to switch on the generator, or is the one going to do maintenance of the generator. A generator is just an example. Or if there's if there is someone, because most of these companies have someone in 24, if it's a 24-hour company, there's people taking shifts to make sure someone is always available there. So these systems have become autonomous. So the roles the engineers don't have to be on site. You can just be taking care of the processing from the comfort of your home or your office. So that is also an impact. Some jobs have actually been, I don't know if that's a positive or a negative thing. Some jobs have been made autonomous, so they don't require money. And also in terms of solar efficiency, in terms of solar efficiency, we get the solar systems that we install right now are smaller in terms of surface area compared to those initially then. So if you have a very small roof or available space is very limited, currently you are able to install a bigger capacity compared to back then. Yeah, I'm trying to read the comments here. I'm seeing Sharon and Chama saying banks partnered to offer loans for cost of green energy as well. It is about financing. Yeah. Yeah. For those who want my contact, there's someone who has directly asked for my contact. You could reach me through info@beyourbest.co.ke for the number there, or yeah, or my personal number, or through LinkedIn. You can be able to also get me through LinkedIn. So John Ngigi is asking, what are the qualifications of training that some can acquire to allow them to get into renewable energy? Happy to follow up after the call. Yeah, the qualifications are, number one, the low-lying fruits are the one-week training courses that are offered in our institutions here in Nairobi. JQuat, Multimedia, KU. I'm actually an alumni of Multimedia University. They have a very good course, a one-week course on T1, T2, solar PV training. Because the other courses, if you want to, if we talk about renewable energy, it spans from wind to hydro to biogas. So the low-lying fruit is actually solar energy. That's why I'm really promoting solar energy, because within 1 week, 1 month, or some few months, depending on how fast you can learn, you can be able to find a footing in solar and go with it. But for the other, such as hydropower, wind energy, maybe nuclear, you need to study for a lot of mechanical stuff to be able to venture into that. Another one is the biogas. Biogas is one form of renewable energy, which you can easily get access to the training in some institutions. Yeah, so T1, T2 is a very good qualification. There's also carbon analytics. There's also, there are a number of trainings, maybe I could share the list later. and there are TVETs, there are colleges, online, even online you can get these short courses online. I've done a few online courses and they're nice because solar is easy to grasp and it's very practical. Yeah. So
Bonge,
okay,
I can see you still have a question from Oscar. Which one is more efficient between solar water heater and hot water heat pumps?
efficiency. You know, when you are comparing efficiency of two different mechanisms, you know, efficiency is actually the energy input, the ratio of the energy input vis-a-vis the energy output. So the solar water heater directly utilizes the sun rays or the photons, to be particular. And the heat exchanger, how is it called it? I'm trying to look for that comment. Oh, Oscar. And water heat pumps. So the heat pumps, they use the normal electricity that we have in the house and connect them to a heat pump. So you can either use any green energy, for example, solar energy. You can have a solar system that powers a heat pump, and the heat pump powers your water. Or you can have the solar water heater that doesn't require any electricity connection if you don't want the boosting. So in terms of efficiency, I would say if you have the solar water heater, it can run in an off-grid, so as an off-grid solution. But for heat pump, you require electricity, so you need to have another source of power, either green energy or just a normal grid. So I can't really pinpoint because they are actually different, their mechanisms are different. But I could say the solar, to me, I would choose the solar water heater because it can run in an off-grid. It provides savings, 100% savings. And also the heat pump, it uses the normal water heating elements. So there's a lot of energy losses in that. Yeah. So maybe Oscar Kipkirui, we can maybe have a chat later on about this. Have I exhausted all the questions?
No, I can see there's a final question here. So the question is, how would you compare solar water heater to boilers? So during my attachment, I witnessed a very big solar company move from solar water heaters to boilers. If it's the efficiency, which is about 21% for the monocrystalline panels, what's being done to counter that?
Pardon, my internet was actually shaking. I didn't get. Could you please repeat?
Okay, so Jerry is asking, how would you compare solar water heater to boilers? So during my attachment, I witnessed a very big solar company move from solar water heaters to boilers. If it's the efficiency, which is about 21% for the monocrystalline panel, what's being done to counter that?
For the solar water heaters, you get the big disadvantages during the cold seasons. Let's say like today, it was a bit where I come from or where I stay. It was a bit the drizzling, raining. So you get that these systems, uh, these systems, they don't run through all seasons. And And a cold season such as June or maybe July, the time where kulikuwa in Kenya where there was a lot of rain, floods, and all the things, you would get the temperatures are very cold. So if you have a solar water heater, the performance was actually low. And for hotels, maybe an example of an industry that requires solar water heating throughout the day and night is a hotel. For a hotel to have no hot water is actually it's not a good scenario. So you would get some of these industries, depending on the energy requirement, if you're using the water as a preheat during your production, you require maybe a certain degree of water, of temperature for the water. So for the solar water heaters, you would get, they really rely on the high season of the sun during the seasons where there is little cloud cover, the sun is out there very nicely smiling on us. So when you get to the cold seasons, you get a lot of complaints. So if you don't have an internal boosting element, it will really be a disadvantage to you. So for this company that moved from solar water heaters to boilers, maybe they installed them during the low peak sunshine hour season, or they weren't really maybe informed in advance when they were doing the installation. Their engineer or consultant didn't inform them of the advantages and disadvantages, because there's nothing that is 100% good. Even the green energy, the solar, the wind, hydro, all of them have disadvantages. So for you to choose your form of green energy, you need to understand fully the advantage. For boilers, you can use boilers also anytime, anywhere, but now you need to have a source of energy. So recently, the boilers and the heat pumps actually, so both of them you can connect to existing energy systems, and if you have a solar system, is actually good. But they tend to deplete our battery banks very fast. So it is not advisable. If you have load separation, it's not advisable to put the batteries in your the boilers connected to the energy storage if you have a small or a limited energy storage system. So I would say that is the major difference for the two. Yeah, so Jerry, that's a good observation.
I can see Jeremiah's hand is lifted. You can go on, proceed.
So I wanted to probably on Jerry's question, he asked at the last part, what is actually being done on maybe increasing the efficiency of these solar heaters. And maybe I would just like to maybe bring to his attention on maybe there's of course some research being going on improving the collector design. Of course, you know, there are different designs of collectors. You have the evacuated, the flat plate, and the concentrated. There are other technologies that are coming up. So maybe can go deeper into maybe researching on what is really being undertaken. Yeah, thank you.
Thank you so much, Jeremiah, for your insight. Any more question or queries? And for those who want to know more about IPEA, you can go to our LinkedIn. You'll find us on our website, which is www.ipea.co.ke. And for those who are interested to talking to Bonke, you can find him on LinkedIn. He's written as Bonke Mulama. And for me, you can also find me on LinkedIn, Cynthia Ongaro. Without, if you have no other question or queries, you can leave at your own pleasure. And thank you all for your time. And looking forward to seeing you again. Thank you. Have a lovely time. Thank you.